It's going to be a quick one, 10 minutes. There's going to be no theory in this. We're going to be talking about HaLow cost gear for HaLow testing. There is a good presentation last year. It's done, I believe, by Troy Martin. I'm not sure, Troy, where? Yep, there's Troy right there. It's a really awesome presentation that goes into the theory. This presentation assumes that you know how HaLow works and all the theory behind it. All right, so when I started the journey, I was like, oh, there's nothing behind me as usual. When I started the journey, I wanted some type of dev kind of boards to work with. And I'm like, okay, I need something I can move as a client, AP, WDS, run bucket capture on it. And I did buy a couple of boards from certain vendors. They didn't really work. I ended up with the H-Core AP, the 112. It's actually the one we gave early as a gift. So you can buy it with every wireless technology known to men. There's LTE radio, a 1x1 HaLow, a 2.4 and 5 Wi-Fi 6 radio, and an IoT radio. That's for $359. Or you can just go for the HaLow version, which is for $199. I would assume that would be the best option, honestly, for the lab. They sell a camera, which is the BL100, for $249. I would say it's a little bit expensive, but if you have the use case, would definitely be worth it. They're insisting on it comes with a 64 gigabyte card, so it must be a bargain for them. So, all right, management OS. So basically, the 112 runs a flavor of OpenWRT actually, and soon it should also has an Open Wi-Fi version. So you should be able to kind of configure it and manage it through Open Wi-Fi controllers. If you're familiar with OpenWRT, you can measure through the command line and do everything you have done in a home router or any OpenWRT AP. But if you're not, you can actually go to their GUI. They have a nice GUI where you can configure the IP addresses, the LAN, the firewall, the wireless side, the HaLow, the other two radios as well. As for the camera, they only provide you with that GUI, which is not that great, but it works. If you don't wanna stream the video to that GUI, you can literally just stream it to any media server. Like in this case, you can see I'm using VLC on my disk. Sorry, not desktop, actually on my laptop. And literally the camera is sitting there on my disk, and I'm just streaming the video to VLC. So you don't have to use their GUI after you configure the camera. All right, so first before we go, this is actually what they look like. This is the EAP, the EAP 112, and this is the camera, the BL100 US. And if we go to the testing, so the first one is EAP to EAP. So what I did is I set up an AP at the red dot as basically, both of them are AP, it's just the role you put them in the network. So the red dot is the AP, and all the yellow dots are client around my neighborhood. So this is how I set up my access point. It's a utility pole outside my house. And no, that's a private, it's just a private utility pole. It's not a utility pole. Every time I post on LinkedIn about any outdoor testing, there's one guy who would go in and say oh, is this legal? I was like, this is all you got from out of this? But yes, this is a private driveway, so there was no laws were broken here. Some free child labor, so those are my two oldest kids. They're actually sitting the APs, doing a terrible job using zip ties. They're actually tied. You can see how the station is set up to my truck there. And I'm going to drive around and get some data. So the setup is very simple. I have my MacBook in my car, HaLow back from the station to the AP, and then a BOE switch powering the access point, and that goes to my Linux home router, just a Linux box running open speed test server. First point at around 1,000 feet away with kind of obstructed line of sight. I got 8 megabit down and 8 megabit up with 8 megahertz bandwidth and NIC 70 dBm on the uplink. And this is a video to show, just to give you a perspective of where the AP, with respect to the access point, like the station. Like I'll try to zoom as much as I can on my iPhone Pro 15. The AP is right there, if you can see it. But this is basically where the AP is. This is second point, going through that building at like 680 something feet. We're getting like, 3 megabit down and up, 4 up at NIG 79 and MCS3 and 8 megahertz bandwidth. This is with like non-line of sight. We're getting half megabit down and 300 kilobits up. This is around, I think, 870 feet away. And then you have another point at like around 600. That's 2 megabit up and down at NIG 78. This one is 1300. So this is no line of sight. We're getting like 180 kilobit down and 13 kilobit up. Not much, but you can still run an IoT device on it. This one at 1400, you're getting 2 megabit up and down at 8 megahertz. This at 1900, actually we're getting down to NIG 91, and we're still holding like 8 megahertz with MCS1. We're getting half a meg down and like 120 kilobits up. The last one is over 200 feet away with really like rough terrain, no line of sight. We're getting 460 kilobit down and 160 kilobit up, which is, in my opinion, still impressive. And you can also see the adaptive rate for the AP is kicking in. Like we went down from 8 megahertz bandwidth to 2 megahertz bandwidth at the edge of the cell. So it is doing the Wi-Fi stuff we all know. All right, so the next was to test the camera with the AP. So basically, I drove around the neighborhood. You can see that path. This is where I lost the feed, like at the further point there. I'm gonna show you, this is where how the camera was set up in my truck, and basically this is the setup. I have my phone connected as back to my home router over a VPN, and then SSH into the access point so I can run a couple of commands. And I have the HaLow streaming back over the AP, back over the VPN connection or 5G, back to my VLC on my phone. And the reason I'm explaining this because of the next video. So this is the first one at 680 through that building. And you can see in this video, the first video on the left will show you where the AP is versus the camera. And the second one is actually a screenshot of or screen recording of the video streaming on my phone. You can see me here walking in front of the camera. You can see a little bit of a glitch. I honestly not sure of that glitch because of 5G. I didn't have really like good coverage, like maybe 1 or 2 bars, or because of HaLow. Like I highly doubt it's honestly HaLow. But remember, this video is going over a VPN 5G over HaLow back to the AP. So I'm gonna run IW commands here to get some, but I need to. I see the timer here, so I need to move. I want to show you guys that next one. So at 1,200 feet away, I lost the feed, and this is a video. It is basically sped up, so this is like almost a 4 minutes video. But I want to show you like how good the video is. Like I'm literally driving at 25, 30 miles an hour. This is an application, like a stationary application, and look at the camera, how good like the streaming is. Remember, it's going back over 5G back to my phone. I'm driving around the neighborhood. 1 more minute. Okay. All right. So this is the video. It's on YouTube also. You can watch the whole thing. So I'm gonna skip to the last point. And then the last testing that I did, I put an AP and a client in a chamber, and I wanted to see how low I can go with the RSSI and maintain 1 megabit per second. And I was able to do that at NIG 97 with 2 megahertz bandwidth, which equates to 1.86 kilometers of line of sight, right? So that's all I have. Seem promising. Hopefully, like with more APs like the 112 and other applications, like we can start have real deployments. Thank you.